Alrighty guys, so in today's lecture we're going to be talking about something called covalent compounds. Now you've heard this term before a few lectures ago. We talked about different types of molecules, and the last lecture we had, we talked about how we have ionic compounds. We talked about what those were. And today we're going to talk about the second type, which are covalent compounds. Now before we do, let's do a quick warm-up just to refresh our memory about some concepts we'll need to know to understand covalent compounds. So let's draw the Lewis structure for these four elements and figure out how many elements they want to gain or lose. So this should be pretty simple by now. All we need to do is look at them row by row. So this is row number 1 and row number 2. So all the elements are in row number 2, so all we need to do is count the boxes to figure out how many valence electrons they have. So lithium is right here. It's the first box in this row, so lithium is just going to have one valence electron. And for the gaining and losing, we just figure out, is it easier to fill up that shell or to just get rid of the electrons? Obviously, it's easier to lose one, so it's going to want to lose one electron because the other option is to gain 7 to fill up that second shell. Fluorine, if you count the boxes, is going to be number 7. It's going to be the 7th box in this row. So fluorine is going to have 7 valence electrons. And it's going to want to fill up that shell, so fluorine is going to want to gain 1 electron. Next we have oxygen, which is box number 6. So oxygen is going to have 6 valence electrons. And it's going to want to gain 2 to fill up that shell. And then lastly we have carbon, which is right here in the middle. It's going to have 4 valence electrons because it's box number 4. And carbon's one of the weird ones where it's not going to want to gain or lose. So this one was the one that we talked about, no MCI. Now, today we're going to be talking about what carbon is going to want to do because carbon plays a very big role in covalent compounds. Okay, carbon has no MCI and it doesn't want to gain or lose. What it wants to do is it wants to share electrons. Now this is something that we haven't talked about before, but just make sure you have this written down somewhere because carbon wants to share electrons, and that's what covalent compounds are all about. Okay? Alright, so let's move on to talk about covalent compounds. But before we do, let's review what we learned last time. So last time we talked about ionic bonds, and the reason why, actually not just ionic bonds, but chemical bonds in general. So chemical bonds, the reason why atoms like to stick together to make chemicals and molecules is because they want to have complete valence or outside shells. This is the reason why elements want to gain or lose electrons. We've talked about this before. Now for ionic bonds, we talked last time that it's when one element gives electrons to another element. So in our warm-up, we did lithium and we did fluorine. We said lithium wants to lose one, and fluorine wants to gain one. And so what's going to happen is lithium is going to give its electron to fluorine. And what's going to happen then is lithium is going to become positive, fluorine is going to become negative, and we know that opposites attract, positives and negatives come together and they create LiF. And so the chemical reaction we talked about for this is going to be Li plus F is going to make LiF. Okay, so that was ionic bonds from last time. Today we're going to be talking about something called covalent bonds though. And in covalent bonds, instead of giving electrons, multiple elements, they were going to share electrons to get full shells. Now what does that mean? Before we talk about that though, we're going to talk about something called the octet rule. So the octet rule is basically a general rule that we can use for covalent compounds. Basically what we want to do is we want to make sure that elements have 8 valence electrons. We just want to make sure that every element in a covalent bond molecule most of the time have 8 electrons. One major exception is going to be hydrogen. Okay, hydrogen wants 2. Okay, so the octet rule basically just means elements are going to always, we just need to make sure they have 8 valence electrons, and the exception is hydrogen, which is always going to want 2. The reason why it's called octet is oct means 8, and so 8, right? So if you had an octagon, you would have an 8. I'm not drawing an octagon right now. I won't draw because you guys already know drawing is bad. But octagon is a shape with 8 sides. Same thing here. Octet rule means they want 8 valence electrons. Okay, so let's draw a picture of how electrons are shared in Cl2, which is chlorine gas, which is a poisonous gas that they used in, I believe, World War I. So what we got to do is figure out what Cl2 is made of. Now, we know that Cl2 is made out of 2 Cl atoms. So what we're going to do is we're going to draw 2 different Cl atoms. Okay, and what we're going to do is we're going to draw the Lewis structure. So if we look for Cl, Cl is in the third row, and it has 1, 2, 3, 4, 5, 6, 7 valence electrons. So we're going to draw 7 valence electrons next to both of the Cl's. Okay, since they're both Cl, they'll have 7. Now, if you notice, Cl has 7, so in order to fill up its valence shell, it needs 1 more. That's how we can get it 8. Remember, octet rule. So both of the Cl's are going to want to gain 1. Okay, so this is different from ionic bonds where one of them wants to lose 1 and one of them wants to gain 1, so it's like a nice transfer. In this situation, both of them are selfish. Both of them want to gain an electron. So instead, what they're going to do, instead of doing an ionic bond where one of them gives an electron to the other, what they're going to do is they're going to share electrons. So what's going to happen is they're going to get super duper close together, and then what's going to happen is this Cl right here is going to get so close to this Cl right here that the electrons are basically going to come together and they're going to share electrons. Okay, so basically what happened is these two Cl's are going to come closer and closer together. They're going to get so close that these electrons almost enter into the other atom. So the key point to notice here is that these two electrons in the middle are being shared. So this chlorine has 8 and this chlorine has 8. So if I scribble this out, if I cover this Cl up, it looks like the Cl on the left has 8, right? 1, 2, 3, 4, 5, 6, 7, 8. But same thing on the other side. If I cover this Cl up, it looks like this Cl has 8. 1, 2, 3, 4, 5, 6, 7, 8. And so basically in a covalent bond, the elements come so close together that the electrons are basically in both atoms at the same time, and they're sharing the electrons, and that creates what we call a covalent bond because they're sharing the electrons in the middle. Okay, so that's what the dots are going to look like or the Lewis structures are going to look like for a covalent bond. But these dots are kind of annoying to draw and they don't look that nice. So what we also can create is something called a stick structure. In a stick structure, every time 2 electrons are shared, all we need to do is just draw one line. So this would be the stick structure for Cl2. Okay, this one right here. Alrighty, let's do a couple more examples just so that you guys are more familiar just looking at these things. Okay, so there are a couple tips that you're going to want to write down because these will be helpful when you guys are creating covalent bond structures. You're always going to put the H on the outside, and so the reason why we do that is because H only wants 2 electrons, and so H doesn't want to connect with more than one element. H is always going to connect with 1. It's only going to have one connection. Okay, carbon and silicon always go in the middle. So just make sure that when you're drawing a structure, you're planning it out, you put them in the middle. And more electronegative elements tend to be on the outside. And so as you go up and right on the periodic table, we know that the elements are more electronegative, so elements that are on the top right tend to be on the outside of the structure. And these will make more sense as we do some examples, but I wanted to give you guys a tip so that you guys can write them down so you have them right off the bat. Okay, so first we're going to talk about structures that have a single bond, where 2 electrons are shared, and we draw one line. Just remember that one line equals 2 electrons. So H2O, what we're going to do is we're going to figure out what this molecule is made out of. We see that it's H2, so there's going to be 2 hydrogens, and there's an O with no number next to it, so it's going to be 1 oxygen. Alright, so what we're going to do is we're going to make sure that we draw the H on the outside. So let's kind of draw it like this. And then we'll put O in the middle. Because we know that H is on the outside, so we put those on the outside. If there's an outside, there has to be inside, and so we'll put O in the inside, which would be the middle. And then we're going to draw the Lewis structure. So for H, H is the first box in the first row, so both H's are just going to have one valence electron. And then oxygen right here is going to have 6 because it's a 6 box. 1, 2, 3, 4, 5, 6. And so what oxygen is going to do is we're going to draw 6 valence electrons next to oxygen. And so what's going to happen is that oxygen we know wants to gain 2. Okay, we learned earlier that hydrogen wants to lose 1, so it looks like it's just going to form an ionic bond, but hydrogen again is a weird one. Hydrogen doesn't want to give up its electrons, it wants to share. And so what's going to happen is that these hydrogens are going to get super duper close to this oxygen, and what's going to happen is they're going to end up sharing the electrons like that. So this hydrogen and oxygen are going to want to share electrons, and this hydrogen and this oxygen are going to want to share electron. And so what that would look like if I kind of drew them closer together. And you don't need to draw it like this for your assignment, but I'm just doing this for the purpose of you guys visualizing it. But basically it's going to look like this. Okay, and if you guys notice, the hydrogens are sharing with the oxygens, right? If I covered up both hydrogens, it looks like oxygen has 8. And if I covered up the oxygen, it looks like both hydrogens have 2, which is exactly what they want. And so if we drew the stick structure for this, we would just write the elements. So we have O, H, and H, and then we would just draw dashes instead of these shared electrons. So this would be the stick structure right here. Okay, so that's what H2O or water molecule looks like. It's basically an oxygen sharing electrons with 2 hydrogens. And just remember that these lines, they represent 2 electrons that are being shared. Alright, if you feel like you could try the next one on your own, go ahead and do so. But if not, I know this is a new concept, so let me go over it step by step. So we have CH4. We can tell by looking at the formula that it's made out of 1 carbon, right, because there's no number next to it, and it's made out of 4 hydrogens. We saw in the rules earlier that we always draw the hydrogens on the outside and carbon and silicon go on the middle. So we have a carbon, so we're going to put carbon in the middle. And we know hydrogens are on the outside, so I'm going to put the hydrogens around the carbon. Okay, for hydrogen, we know that it's going to have 1 valence electron each. We know that carbon is box number 1, 2, 3, 4, so carbon is going to have 4. And if you take a look at carbon, you're going to see that carbon, it has 4 valence electrons. Okay, we read earlier about the octet rule. We need to get that 4 to 8. And so the only way we can get 4 to 8, because this is what the octet rule says, we need to get from 4 valence to 8 valence, is it's going to share with this hydrogen. Now this hydrogen's happy because it has 2, but this carbon has 1, 2, 3, 4, 5, so it's going to make another connection with this hydrogen. Now this hydrogen's happy because it has 2, carbon has 6, and you kind of get the pattern. And as they do that, all the hydrogens, if I cover up the carbon, all the hydrogens have 2. But if I cover up all the hydrogens, you're going to see that they all have, or the carbon has 8 valence electrons. Okay, so if I drew the stick structure for this, I'm basically just going to copy where the positions of where the elements are. And then since there's only 2 electrons being shared, right? 2 electrons shared is 1 line. So I'm going to draw 1 line. And this would be my stick structure. Okay, and what we call these lines is a single bond. And we call it a single bond because There's a single line, right? There's 2 electrons being shared. So H2O right here, it's going to have 2 single bonds because there are 2 lines. CH4 has 1, 2, 3, 4 lines, so it's going to have 4 single bonds. Alright, and so that's just some practice on how to draw covalent structures and how to draw single bonds. Single bonds is when there's one line, which is 2 electrons. Okay, so if there's a single bond, that means there's also something called a double bond. Okay, and there's also going to be something called a triple bond. Now, this seems really intimidating, but it's basically the same thing as earlier. We said that when we have a single bond, we have 2 electrons that are shared, and it's one line. Okay, so if it's 2 electrons for one line for a single, a double is 4 electrons for 2 lines, a triple is 6 electrons with 3 lines. And we'll do a couple examples. So we have O2. So we can see that O2 is made out of 2 oxygen molecules or atoms. And if you count the boxes, 1, 2, 3, 4, 5, 6, oxygen is going to have 6 valence electrons. We know that oxygen, both of them want to gain 2. So that means they need 2 to get to 8. And so what oxygen is going to do is going to share with this oxygen. And you're going to notice that both oxygen have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And so we're going to have to share one more pair in order to get them to 8. Because look, if I cover this oxygen up, how many electrons does this oxygen have? It has 2, 4, 6, 8. And if I do the same thing, if I cover this oxygen up, this one has 2, 4, 6, 8. And it's because they're sharing the valence electrons. And so if I drew the stick structure, it would look like this. I just copy down where the O's are, and it looks like they're sharing 4, right? If 4 electrons are being shared, I draw a double bond. And so this is the stick structure. And this compound right here, O2, is going to have 1 double bond. Okay, another example that we have here is CO2. It has 1 carbon and 2 oxygens. And so remember, we have to, if we look back at our rules, carbon is going to go on the inside, and so we'll put the oxygens on the outside. Oxygen, we said earlier, has 6 valence electrons. And carbon is box number 4, so it's going to have 4 valence electrons. Okay, now remember the octet rule. Always remember the octet rule. That just means that we want to have 8 valence electrons for every single element. So we need to make these elements share electrons so that they all get to 8. So what we're going to do is oxygen is going to want to share 2. So oxygen is going to share with carbon right here. Oxygen, if you notice, has 1, 2, 3, 4, 5, 6, 7. So it's not happy, so what it's going to do is going to share another pair. Now this oxygen is happy. It's good to go because it has 1, 2, 3, 4, 5, 6, 7, 8. But this carbon right here has 1, 2, 3, 4, 5, 6. It wants to share 2 more. Now we know that this oxygens want to share 2. Carbon needs 2 more, so naturally we know where it's going to share from. It's going to share with the other oxygen on the opposite side. And now everybody is happy. If you want to pause the video so you can count if you want to count and make sure that they all have 8, you can do so right now. But they all have 8 electrons now. And so if I drew the stick structure, I'm just basically going to copy down the positions of where the elements are. And if you notice that between this oxygen and this carbon, there are 4 electrons being shared. So if there's 4, I'm going to draw 2 lines. And here, there are also 4, so I'm going to draw 2. And so this is what the stick structure of CO2, carbon dioxide, the air that you're breathing out right now, is going to look like. And it's going to have 2 double bonds. Okay. So O2 is the oxygen gas that you're breathing in right now. It's what you die if you don't breathe, and it looks like this. And CO2 is what you're breathing out, and it looks like this. Okay, so those are double bonds. Basically, it's just doubling the single bond. Single bonds are 2 electrons, 1 line. Double bonds are 4 electrons, 2 lines. Okay, lastly, we have a triple bond, and that's going to be basically naturally 6 electrons with 3 lines. So an example of that would be N2. We know that N2 is made out of 2 nitrogens, so we have N and N, and if you count the boxes, N is on box number 1, 2, 3, 4, 5. So they are both going to have 5 valence electrons. Okay, and we said octet rule, we want to get them up to 8 valence electrons each. And so if they have 5 to get to 8, they need to have 3. And so what's going to happen is since they both need 3, they're going to share 3 electrons with each other. And so if I cover this nitrogen up, you're going to notice it as 1, 2, 3, 4, 5, 6, 7, 8. And if I cover up the other nitrogen, I'm going to see that there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if we wanted to draw our structure, all we need to do is copy down the positions of the elements and notice that there's 6 electrons being shared. So we're going to draw 3 lines, and this is going to be our stick structure. Okay, and for the bonds we have 3, or oops, not 3, we have 1 triple bond. Okay, so that's basically the gist of covalent compounds. Covalent compounds are where the electrons are being shared between the elements, and all we need to do is make sure that everybody gets 8. That's the octet rule. Now, before I let you guys go, we're going to try one example, and this might seem a little bit hard, but let's remember our rules. So if you have your rules written down, make sure you guys go back to them. All right, so we have this compound, CH3, CH2, CH3. So you might be wondering, like, what the heck am I supposed to do here? It's pretty simple, though. When you have something that looks like this, where you have CHs or you have these repetitions, it means they're kind of going to be in that order. So that when we draw the covalent structure, it's going to be a CH3 on the left side, a CH2 somewhere in the middle, and a CH3 on the right side, right? Basically, I just broke it up. But, I mean, they're all going to be connected together. But just make sure you know that if they're written out, if the elements are split up like that, that's basically kind of the structure of the molecule. So let's start with the left side. There's CH3. Now we learned from one of our rules earlier that H's are going to go on the outside and carbons go on the inside. So we know that H's always go on the outside and carbons always go on the inside. Okay, so I'm going to draw C in the middle and I'm going to draw the H's around it. Alright, and we know that H has 1 valence electron because it's the first box in the first row. And C, carbon, we said earlier, has 4 because it's the 4th box in the second row. So it's going to have 1, 2, 3, 4. Okay, so we did CH3. Okay, we have to do CH2, and CH2 is going to be in the middle somewhere, so we're going to do that. We already know the valence electrons. H is going to have 1 each. Carbon is going to have 4. And then lastly, we have CH3, which is kind of just a mirror of this side right here. Okay, one thing you need to keep in mind, though, is that all the elements need to be connected. Okay, they all have to be connected. So what I mean by that is that I cannot do this. I can't connect these H's because if I do that, the H's are happy. They're not going to connect with the rest of the molecule, but that's not what the molecule looks like, right? If they're all written together like this, they all have to be connected. What that means is every single atom in a covalent compound has to be connected with the rest of the molecule. They all have to have at least a single bond between them. Alright, so what that means is that the hydrogens, if you notice, they grouped it, the formula is written grouped up with CH3. That means these H's are going to be connected with this carbon. So we're going to connect the H's with this carbon. And if you notice, if you look at them, all the H's are happy because H wants 2 valence electrons and all of them have 2 now. If we move on to CH2, CH2, the H's are going to be connected with that carbon. And if you notice, all the hydrogens are happy. And then obviously the CH3 on this side is going to be basically the mirror of the left side. So if you take a look at all of the H's, and you can take a second to pause the video and count them up, but all the H's are now connected with the carbons. And all the H's are happy because they all have 2 valence electrons. But if you take a look at this first carbon right here, this first carbon is not happy because it's only going to have 1, 2, 3, 4, 5, 6, 7. This one has 7 valence electrons. And we know that octet rule, we need to get it to 8. So it needs one more connection. This carbon needs one more connection. So it's next to another carbon, so we're going to connect it with that carbon. And now this carbon is happy because it has 1, 2, 3, 4, 5, 6, 7, 8. This carbon right here, if you count them up, it has 1, 2, 3, 4, 5, 6, 7. So it has 7 electrons, and it needs to get to 8. So that means this carbon needs one more connection. And obviously this part of the molecule is not connected yet. And so we're going to combine those. And so this carbon is going to be happy now. And if you look at the carbon on the right, it has 8 connections now. So that carbon is happy. And so our checklist should be number 1. And this will help you check your answers and make sure you get everything correct for the quiz at the end of this week. Is number 1, sorry, not is, are all the atoms connected? So make sure that everything is connected. Here, everything's connected. Number 2, do all the atoms have 8 valence electrons? Okay, so obviously hydrogen has 2. So those are the questions that you should be asking yourself. Number 1, are all the atoms connected? If you notice, they're all connected. Do all the atoms have 8 valence electrons? And if you notice, they all have 8 except hydrogen, which is supposed to only have 2. So if I wanted to draw the stick structure here, I would just copy down the elements where they are, and then just figure out what kind of bond is between all of them. So if you look at the hydrogens here, they have a single bond. So I'm going to draw single bonds, right? This is a line, this is a line, this is a line. Between the first 2 carbons, it's a single bond because only 2 that are being shared. Hydrogens and carbons on this one are one line. This is also going to be one line because it's only 2 electrons being shared. And so this is what our stick structure is going to look like. And if we wanted to count the bonds, how many bonds there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 single bonds. There are 10 single bonds in this molecule. Alrighty guys, so hopefully that was helpful. Let me know if you guys have any questions, but your assignment is posted on Canvas and I'm on Zoom if you have any further issues or questions about covalent bonds. Good luck, and I'll see you guys next time.